Continuity, part 5, question number 1. Discuss the continuity of function at x equal to 1 upon root 2. Function is given as x minus cos sine inverse x divided by 1 minus tan sine inverse x when x does not equal to 1 upon root 2 and it is minus 1 upon root 2 when x equal to 1 by root. Let's find out LHL. LHL limit x tends to 1 upon root 2 minus, and function is x minus cos of sine inverse x divided by 1 minus tan of sine inverse x. Now let's make some assumptions. Let sine inverse x equal to y, then it will give x equal to sine y. And here, when x tends to 1 upon root 2 minus, then y will tends to pi by 4. So we evaluate it, it will become limit y tends to pi by 4, then x will become sine y minus cos y divided by 1 minus tan y, which is equal to limit y tends to pi by 4 sine y minus cos y divided by tan y can be written as sine y upon cos y. When we take LCM, it will become cos y minus sine y divided by cos y. So we can write cos y here. Now, these two will cancel out, leaving minus 1 because this is sine y minus cos y. This is cos y minus sine y. So we will get limit y tends to pi by 4 minus cos y. If we put the value of pi as pi by 4, we will get minus 1 upon root. LHL and RHL will be same because same function is to be considered. So I'm not doing that. And value of function at x equal to 1 upon root 2 is also minus 1 upon root 2. Hence, we can say that LHL equal to RHL equal to value of function at 1 upon root 2. So function is continuous. Let's go to next question. If f is continuous on 0 to pi, then find a and b. Function is x plus a root 2 sine x when limit is 0 to 0 is less than x is less than pi by 4, then 2x mod x plus b pi by 4 is less than x is less than pi by 2, then a cos 2x minus b sine x when pi by 2 is less than x is less than pi by 2. So here, first we will try the function to be continuous at x equal to pi by 4, and then at x equal to pi by 2. So first let's consider x equal to pi by 4. So LHL limit x tends to pi by 4 minus, then function is this one. So x plus a root 2 sine x. We can put the value. So it will become pi by 4 plus a root 2 into sine pi by 4 is 1 upon root 2. So this will give pi by 4 plus a. We have got LHL. Now consider RHL. Limit x tends to pi by 4 plus. This time function is 2x mod x plus b. Here also we put the value of x as pi by 4. cot pi by 4 is 1. So 2 into pi by 4 plus b. That is pi by 2 plus b. Now we consider this value x equal to pi by 2. So let's consider LHL. LHL is limit x tends to pi by 2 minus, the function is this 2x cot x plus b, and if we put x equal to pi by 2, cot pi by 2 will become 0, so we will get b. And now consider RHL, limit x tends to pi by 2 plus, then this time we have to consider this function. So a cos 2x minus b sine x. So we can put the value. It will become a cos I minus b sine pi by 2, which is 1 sine pi by 2. So cos pi is minus 1. This will be minus a minus b. Now we have got these relations, this thing, and this thing. So they all must be equal. So let's write them. So we have a relation pi by 4 plus a equal to pi by 2 plus b. So from here, a minus b will be pi by 2 minus pi by 4. So we take LCM, it will be 4. So 2 pi minus pi, that is pi by 2. So this is first relation. And then there is another relation. The same value is equal to minus a minus b. Another value is minus a minus b must be equal to pi by 2. So if we add these two values, this a minus b equal to pi by 2 minus a minus b equal to pi by 2. So we get minus 2b equal to pi, because pi by 2 will become pi. So b equal to minus pi by 2. And when b equal to minus pi by 2, we put here, so we get minus a equal to pi by 2 plus pi by 2. And this will become pi. So minus a, which gives a equal to minus pi. So we have got the answers. Now let's go to next question. For what value of k the following function is continuous at x equal to minus pi by 6? Here function is continuous, so we are directly going to evaluate x tends to pi by 2. So limit x tends to, sorry, we are going to evaluate x equal to minus pi by 6. So minus pi by 6, and we write this function root 3 sine x plus cos x divided by x plus pi by 6. So this will become limit x tends to minus pi by 6. What we do, we can multiply by 2 and divide by 2. So root 3 by 2 sine x plus 1 by 2 cos x divided by x plus pi by 6. Now we can write it limit x tends to minus pi by 6 twice. This will become sine x cos pi by 6 plus cos x into sine pi by 6 whole divided by x plus pi by 6. So this will become limit x tends to minus pi by 6 twice sine x plus pi by 6, because formula sine A cos B plus cos A sine B is sine A plus B divided by x plus pi by 6. Now this will become 1, but for that let's do some more steps. So let x minus, let x plus pi by 6 equal to y when x tends to pi by negative pi by 6, y tends to y tends to 0. So this will become limit y tends to 0 twice of sine y divided by y. So this will give 1. So answer will be, hence value of k is 2. Let's consider next question. If f is continuous at x equal to 0, then what is value of k? Let's consider solution. Here again, we will consider LHL RHL together. So we just write limit x tends to 0 and we write function cos square x minus sine square x minus 1 divided by root of x square plus 1 minus. So it will become limit x tends to 0. This can be converted into sine. So it will be 1 minus sine square x minus sine square x minus 1 divided by root of x square plus 1 minus 1. So limit x tends to 0, and this will become minus 2 sine square x. And what we can do, we can rationalize denominator. So if we rationalize, then this root will get cancelled. X square plus 1 minus 1 times the root of x square plus 1 plus 1. Now 1 will cancel out. So we will get limit x tends to 0 minus 2 sine x upon x whole square times root of x square plus 1 plus 1. So this will become minus 2 into 1 into, if we put value here x equal to 0, so 0 plus 1 plus 1, that is minus 2 into 2, that is minus 4. So value of k is minus 4. Consider next question. Check the continuity of f at x equal to 0. So LHL limit x tends to 0 minus e power 1 upon x minus 1 divided by e power 1 upon x plus 1. So it will become e to the power minus infinity minus 1 divided by e to the power minus infinity plus 1. So that will give minus 1 because e power minus infinity is 0. Now consider RHL limit x tends to 0 plus e power 1 upon x minus 1 divided by e power 1 upon x plus 1. This can be written as limit x tends to 0 plus 1 minus 1 upon e to the power 1 upon x divided by 1 plus 1 upon e to the power 1 upon x. When we put x equal to 0, then e power 1 minus 1 upon e to the power infinity divided by 1 plus 1 upon e power infinity, which will be 1. So LHL is minus 1, RZ is 1, and value of function 0. So all three are different. It means function is not continuous. Now let's see next question. If f is continuous at x equal to 0, then find the value of k. So here fx is given as log 1 plus x minus log 1 minus bx divided by x when x does not equal to 0 and it is k. So let's consider LHL. LHL is here again LHL and RHL will be equal. So limit x tends to, I'm taking directly limit x tends to 0. So limit x tends to 0, right function log 1 plus ax divided by 1 minus log 1 minus bx divided by x. If you remember, limit x tends to 0 log 1 plus x upon x is 1. So here, same thing. Here a is missing. So what we can do, we write it limit x tends to 0 log 1 plus ax. We multiply a here and then we write in denominator ax minus. Here again, we write minus b and log, so there is minus sign, 1 minus bx divided by minus bx. So if this x is written here, I have divided it separately. So this will become 1. This term will also become 1. So we will be left with a plus b. So we can say that k equal to a plus. Now consider next question. If function f is continuous at x equal to 0, then find k. Here function is 36 power x minus 9 power x minus 4 power x plus 1 divided by root 2 minus root 1 plus cos x when x is not equal to 0 and k when x equal to 0. So we are going to take it to direct limit. So a limit x tends to 0 and we write some 36 power x minus 9 power x minus 4 power x plus 1 divided by root 2 minus root 1 plus cos x. Here 36 power x can be written as 4 into 9 power x, that is 4 power x into 9 power x. So limit x tends to 0, 4 power x into 9 power x minus 9 power x minus 4 power x plus 1 divided by root 2 minus root 1 plus cos x. So limit x tends to 0. If we take out 9 power x, 4 power x minus 1 will be left. And from here, we take out minus 1. Then 4 power x minus 1 will be left. Divided by root 2 minus root 1 plus cos x. Now we write limit x tends to 0. And then it will become 9 power x minus 1 times 4 power x minus 1 divided by, we rationalize the denominator, so it will become 2 minus 1 plus cos x times root 2 plus root 1 plus cos x. So this will become 1 minus cos x. So 9 power x minus 1 times 4 power x minus 1 divided by 1 minus cos x times root 2 plus root 1 plus cos x. Now let's see further. So it will be, we can write it, limit x tends to 0, 9 power x minus 1 upon x into x into 4 power x minus 1 upon x into x into 1 upon 1 minus cos x can be written as 2 sine square x by 2 times root 2 plus root 1 plus cos x. Now this will become, if you remember the formula, e power x minus 1 upon x is log a. So it will become log 9 into log base e 4 into this x, and this x can be written as x square, and we want to make this, we write 2 here, and here sine x by 2 divided by x by 2 whole square, and to cancel this we write x square by 4, so we can take 4 here, and root 2 plus root 1 plus cos x. Now further, so it will become log 3 square log 2 square into this x square will cancel out, this 2 will make it 2, and if we put x equal to 0 here, so it will give root 2. Root 2 plus root 2 will give 2 root 2, and 1 2 is here also into 2. So this is 4 root 2, and this 2 will come over here. Property of log n power n gives n log n. So 1 2 from here and 1 2 from here. Then log 3 base e times log 2, sorry, log 2 base e. So this will come 16 root 2 times log 3 times log 2, which is our answer. Thank you for watching.